In this lecture, we will be examining the physical geography of the region we are today calling Ohio. An understanding of Ohio's physical features helps us recognize the role that geography plays in the directions that history sometimes takes. Pictured here is the Laurentide Ice Sheet, or at least a map depicting it, which was a mass of glacial ice that once covered over 500,000 square miles. This was during a period known as the Last Glacial Maximum, or LGM. This massive sheet of ice was one of many that have ebbed and flowed across the American continent in the various ice ages in the Earth's past. This sheet once stretched across much of Canada and the northern United States. At its greatest extent, it covered approximately 1/3 of North America, or at least the landmass of North America. It went as far south as the St. Louis, Missouri. It was up to 2 miles thick and had largely receded to its present area by 6000 BCE. This next map shows in greater detail some of the subsections of glacial ice that once made up the Laurentide Ice Sheet. As you can see, the geography of the northern and western sections of the state of Ohio was significantly affected by the movement of ice sheets across the landscape. One of these large ice sheets was known as the Erie Lobe, L-O-B-E. As the Erie Lobe retreated to the northeast, it left behind significant deposits of debris known as moraines, M-O-R-A-I-N-E-S. These moraines ran at right angles to the path of the retreating glacier. Pictured in this image are glacial grooves on Kelly's Island, which is in southern Lake Erie. The grooves and markings you see here were created as the receding glacial ice, which contained boulders and stones, carved out the comparatively soft limestone that was underneath. The limestone contains millions of marine fossils, but unfortunately much of the original glacial grooves were quarried away in the late 19th and early 20th centuries. This particular stretch on Kelly's Island, which is one of the finest examples that you will see in North America of glacial grooves, is about 400 feet long. It's about 35 feet wide, and at its deepest is about 10 feet deep. This next map shows the variety of sediment types in present-day Ohio, and this reflects in large measure the glacial activity that we've talked about already in this presentation. The greenish hues, or greenish colors in this map reflect sediments that were deposited directly by glaciers. The pinks and yellows in this map are glaciofluvial, G-L-A-C-I-O-F-L-U-V-I-A-L. Glacial fluvial deposits, which are associated with water that flows in, on, or under an ice sheet. And the bluish colors are glaciolacustrine sediments, G-L-A-C-I-O-L-A-C-U-S-T-R-I-N-E. These sediments were deposited in lakes that were associated with ice. There are a number of distinct physiographic regions in Ohio. Physiography, which is a term simply enough derived from the phrase physical geography, is a method of categorizing the planet's landforms into distinct regions. The first of these that we will explore is the Huron-Erie Lake Plains region, which emerged as a result of flat-lying clay and silt beds that were deposited in lakes trapped in front of retreating ice masses. In the case of Lake Maumee, that we'll talk about in a moment. This region is the former bed of Lake Maumee. This region is punctuated by relic sand dunes. It has beach ridges and end moraines. So as the ice ebbed and flowed, and as the water ebbed and flowed, it left behind sediments. This area is noted for relatively poor soil drainage. The Till Plains region features flat to sort of undulating topography. It's dominated by glacial deposits, mostly tills in moraines. This is a gently rolling landscape that is interrupted by larger hills. It's also one of the most fertile farming regions in the United States, and the till plains, in terms of agronomy or the study of agriculture, mark the beginning of what is known in the United States as the Corn Belt. The glaciated Allegheny Plateau, as you can see on this map, is located in northeastern Ohio. It is light blue on this map. This is an upland area that's dominated by mixed deposits and landforms. The region is also noted for dissections of deep through valleys and rivers that drain into the Ohio River Basin. This is a hilly region, but is mostly lower hills with gentle slopes. Next, we come to the Appalachian Plateau region of Ohio. There are two distinct subtypes to the Appalachian Plateau region. In the northern part, the dominant features are rolling hills and valleys. The southern two-thirds, though, of the Appalachian Plateau feature steep hills and deep valleys. This is the most rugged area in Ohio, and among the least populated area in Ohio as well. The soil here is quite thin and not very fertile. This region is noted for very beautiful scenery, for abundant mineral deposits. For example, the Hocking Hills State Park is typical of the natural state of the region. In short, the presence of glaciers in Ohio altered the landscape. It eroded valleys and smoothed hilltops. There was quite a bit of sediment that was deposited. New landforms were created. Watersheds were altered. There were a number of regions in which there was depressed land. That's depressed in terms of heavy weight forcing it downward as opposed to needing Prozac or something. This is known as isostasy, I-S-O-S-T-A-C-Y, if you're into physical geography. Lake levels changed as a result of the presence of glaciers. So Ohio, very much modern Ohio, shaped by glaciers. This next graphic shows the change in time of the body of water that we now call Lake Erie. The upper left corner of the image is of approximately 15,000 years ago. You can see all of what would become Lake Erie, and the Great Lakes themselves were underneath this ice sheet. Moving from top to bottom and left to right, each image represents approximately 1,000 years of change, with the bottom right corner being the region as it looked approximately 9,500 years ago. This map depicts glacial Lake Maumee, which was a precursor of the present-day Lake Erie. The lake formed approximately 14,000 years ago, and its presence changed the geography of northwest Ohio, southeastern Michigan, and eastern Indiana. One of the effects of the receding waters and ice associated with Lake Maumee was the creation of what became known as the Great Black Swamp. At its peak, the Great Black Swamp was over 40 miles in width and 120 miles in length, and at one point the swamp once encompassed nearly 10,000 square miles in area. The Great Black Swamp proved to be a barrier to white settlement in the region, and it was not drained and settled until at least heavily until the second half of the 19th century. Even for Native American groups, this was more of a region for hunting or short-term habitation rather than major settlements, which tended to be a little ways away from the swamp. There were a few noteworthy exceptions to this, but even those tended to be on prairies or ridges, not in the swamp itself. It was a very mosquito-laden place, as we will talk about later in the course. These days, the land that once made up the Great Black Swamp is highly productive farmland. In this next image, you can see some of the features of the swamp. The red indicates the ancestral Black Swamp, the Great Black Swamp. The yellowish region shows portions of Indiana that were once part of the swamp. The border of the watershed, or the sort of the boundaries of the swamp, are noted by the dotted lines here. And you can see that the Great Black Swamp encompassed areas of southeastern Michigan, eastern Indiana, and much of present-day northwest Ohio. This is an image I took of remnants of the Great Black Swamp in western Lucas County. This particular patch of swamp is located about 15 miles from downtown Toledo, Ohio, due west. There are many such small pockets of swamp that remain in northwest Ohio. I suspect that if human habitation ended suddenly, it would probably be just a matter of 5 to 6 decades before the land returned to its natural swampy state. Without the drainage systems being maintained and the pump systems that divert water away from flat land and into the creeks and rivers that drain into the Lake Erie watershed, the swamp would quickly return. Finally, this map describes another important feature of the physical geography of Ohio, which is the post-glacial continental drainage divide. This is part of a national or continental divide that cuts east to west across the state of Ohio. Surface water north of this divide eventually flows into Lake Erie, then through the Great Lakes and St. Lawrence River Basin into the Atlantic Ocean. Surface water to the south of this divide flows into the Ohio River Basin, then to the Mississippi River and the Gulf of Mexico. And this brings to a close our brief look at the physical geography of Ohio.